let's start the some Doppler effect. Is a purely kinematics based one. So what a student has to go back to the like most of the problems that you are going to come across will be application based, like what we have studied in the mechanics, no, will be correlated with that mechanics. Now, after this, we will. What do you mean by Doppler effect? So let's begin like this. I'll start with the example like this. So this is the source. This is a detector. Detector, what happened? I'll write it as observer or detector. Both are same. So the source will emit waves. So usually you take like this. If this is a source, what it will do? It will emit waves. Usually it's a point source, no? So therefore, these are the waves what you can take it. And in what action the wave will propagate? The wave will propagate radially outward. This is the direction of the wave propagation. What is that red color arrows will give the direction of wave propagation. What are that concentric circles? They're not concentric circle, plane diagram concentric circle. In fact, here you can select a spherical wavefront. So we'll call them as spherical wavefront. Water, oh, no, I'll bring them together. I'll bring them together. So this will generate a sound, no? This will generate a sound. So they'll undergo superposition, not like inside. Huh? See, organ pipe, what when you play that one, what when the sound energy should escape from the organ pipe, no? So they'll undergo superposition. The energy will come out of organ pipe, no? There we are discussing. Okay, ma? Yeah. Now this is spherical wavefront. So now what do you mean by wavefront? First of all, we'll discuss wavefront. So it's a plane in which all particles will have same phase. Okay, agree this? So what do you mean by wavefront? It's a plane in which all particles will have same phase. Suppose say if I say the phase of this is 0, the phase of this is say like a 2 pi. Anything, let me take 4 pi, then 6 pi. The phase. Then we know the distance between 2 pi and 0 should be the lambda. So like this, we can now define the distance between these wavefronts will become lambda. You can draw anything. So these are very things like a all points here will have 0 phase. All points in this wavefront will have phase of 2 pi. What is the distance between 2 points where they'll have same phase? 0 and 2 pi are same. Both will be at mean position moving in same direction. So therefore, what is the distance between 2 points having same phase? That will be called lambda. So like that, if I draw a spherical wavefront, so the distance between wavefronts will become lambda. Sir, I will draw 0, pi, 2 pi, 3 pi. In that case, lambda by 2 will come. So you can also think in this way, nothing wrong. Okay, so some are asking, sir, like if it is this, I'll say phase 0, pi, 2 pi, 3 pi. In this case, what is lambda? The lambda will be, this will become lambda by 2. Am I right? I think you know enough of mathematics. Lambda by 2, lambda by 2, lambda by 2. Like this, you can no, sir, I will draw 0, pi by 2. In that case, what should be 0, pi by 2? Should be lambda by 4. Like this, you can draw infinite wavefronts. We are more interested of the wavefronts which are having a phase of 2 pi radians, the phase difference between them, like 0, 2 pi, because that will become one wavelength, no? So therefore, I'm just showing it. Okay, got the idea now? So what in general the source will generate a wave. And what is a wave? So like the plane in which all particles will have same phase, it will be, we'll call wavefront. So there's a point source. So because as it is a point source, what happens? Spherical wavefront will come. So what is S we should call? What is S? S is a okay, in some brief idea. This is like this. There's a point source. I kept it. So what is this situation? What is the condition of this point source? It is at rest. Is a detector is also at rest. So this is a detector or observer. Anything you can put it. If he is far away, if the source is far away, how do this spherical wavefront will appear like a plane wavefront? Okay, those wavefronts is what I'm going to show it. If that particular wavefront is far away, how do it will become plane wavefront? Means if the waves are coming from far away, the wavefronts what happen will become like a plane wavefront. If the waves are coming from far away, you can treat like a plane wavefront. Got the idea now? So it will be like this. Now, with what speed the wavefront will be moving? So what is this arrow? Direction of propagation of a wave. This is the initial arrow. Similarly, how the direction of propagation will be? The direction of propagation, the speed, the velocity of the wave will be directed perpendicular to the wavefront. So here in what direction the wavefront now it is propagating? So definitely I can say that it is. This is the speed of the sound. I'll write VW or V. Capital V is what will be using it, the symbol specifically, or if you want, you can write it U also, anything that will. Now, what is the distance between wavefronts? Should be lambda. Now, sorry, earlier you wrote concentric circles. Now what happened? You are putting parallel lines. This is a plane wavefront. When spherical, if you're nearby point source, spherical wavefront. If you're far away from the point source, then the wavefront what happen will appear like a spherical. A good example, if you're far away, almost, can you draw a straight line here? That's all, no? If you're far away. So if you draw a big circle, and the big circle, you can assume it to be like a straight line, because what is the circle again made up of? Like a n number of straight lines only. So if the observer is far away from the source, so then we'll get a wavefront like this, plane wavefront. The distance between wavefronts will be lambda. Now, the source will be continuously emitting waves, no? So what is the time taken to come to emit one wavefront? Means first this is the t equals 0 is emitted. After what time this is emitted? After certain time. So that is called like a time period t. Now this t is equal to nothing but shall we write 1 by f. And what is f? Frequency of the source. F naught, I'll write it. Or let it be f only, you'll get confused. So what is f? Actual frequency of source. What are the equations we can write? Speed of the wave, f is equal to v by lambda. Or this f further, you can write it as 1 by t. So in fact, lambda, what you can write? Vt. Now what is a t? For every interval of time t, one wave will be emitted. So when do first this will come at t equals 0? When do the second wavefront will come? After some time t. When do this wavefront has come? After 2t, 3t, 4t, 5t. So for every one time period t, one wavefront will be emitted by this. You should have this imagination. So, sir, we are finding really very difficult. Okay, you assume this is like a person, your teacher, physics teacher, and you are here. I'm going to throw a duster. So what is this capital T? For let this capital T be say 2 seconds. For every 2 seconds, I'm going to throw one duster with a certain speed. Then the duster sort pen will be continuously will be moving. Imagine, because the duster will describe parabolic path. I'm asking you to imagine. For every 2 seconds, I'm going to throw one duster. Tell me like the dusters will be moving, no? There's a first duster I thrown it. When the second duster will be thrown after 2 seconds. T equal to 0, 2 seconds, 4 seconds. So the duster will be moving with a speed. What will happen to distance between dusters? Will remain same, no? How to calculate the distance between dusters? There's a formula. Lambda equal to Vt. And what happened to these dusters? Will for every 2 seconds, one duster will come and strike you. Am I right? Will bang your head. Next again after first T equal to at some time, it will strike it. After 2 seconds, second duster. After again 2 seconds, again third duster. For every 2 seconds, one duster will be coming and striking it. Able to analyze? This is the basic idea. Now, what will happen is the source will remain fixed. It will not move. The source will be at rest. It will generate a sound signals of this frequency. This is source. The observer will start moving. Tell me like anything will happen to the distance between dusters. Whether you are at rest or you are in motion. So what the teacher will be throwing for every 2 seconds one duster. So what will happen to distance between dusters? Will it remains constant or varies? It's a kinematics one, nothing to do with the physics much. The waves and sound concept. Anybody answers? What happened to distance between the dusters now? The physics teacher for every 2 seconds is throwing one duster. Okay, got this one. And the dusters are thrown with a certain velocity v. If you are at rest for every 2 seconds, one duster will come and strike with a speed v. If you start moving, tell me what will happen. The distance between dusters will change. Anybody wants to answer? The distance between dusters will it change? Yes or no? All of you sleeping or hearing class? No, the distance between dusters will not change. There's an idea. There's an idea here. The distance between dusters will not change. Okay, earlier what was the distance? So it will remain same. And now with what speed they'll come and strike you? With the same speed or different speed? Relative velocity, take help of relative velocity. So I should put the same lambda. Now with what speed the waves will come and strike? So what are these? These are again the wave front. With the same speed they'll strike or with a different speed? With a different speed they'll strike, no? Okay, now what happened? The signal was generated frequency f is going to hear at different signal frequency. The reason for that, the wavelength will not change, but the speed with which is going to receive the waves is going to change. So what is the signal now? F dash is equal to V relative by lambda. So why you are not changing lambda? Because we know the distance between wavefronts should not change, but the speed with which the waves strike the observer will be varying. So earlier now, so first case what we write, the wavefronts strike the observer with speed v. Now in this case, the wavefronts will strike the observer with speed v relative. There's a core idea. Okay, how to calculate that v relative? Anybody wants to answer? Shall we write V naught plus V or V plus V naught? Why it is V minus of minus V naught, no? Because how the observer moving towards left, wave is moving towards left, towards right. V means wave speeder. I think I wrote somewhere. Let me put that. Or speed of sound. Okay, no. This one. So what is F dash? F dash is equal to V plus V naught by lambda. What is lambda? Lambda is Vt. What is 1 by T? Should be equal to F. So now what about the frequency at which he is going to? He is going to hear the sound signal at different frequency. Why do this happens? Because there's a relative motion between source and observer. I'm putting the complete description in front of you. Got the idea, no? There's a very small basic thing. So why is going to hear now at different? This is called as apparent frequency. Now the detector, the observer, what happened now is not going to hear the sound at a frequency f which is generated. It's going to hear it at different frequency. How to calculate that? Apparent? Apparent means appears to be. Again, if he stops moving, if he comes to rest, he's going to hear the signal, sound wave. He is going to hear the signal again at frequency f only. The moment he starts running, he's going to hear it at different frequency. Able to understand this one? What is V naught? What is V naught? V naught is speed of observer. What is V? Speed of sound wave or signal. And now if observer moves away, any changes, will you make it here? If the observer moves away, here I'll make changes. The observer, in fact, will move away now. You have the discussion here. Tell me like what is V relative in this case? Plus V. Okay, I agree this, the condition. So then what is apparent frequency? F dash V relative by lambda. What is V relative? V minus V naught. What is lambda? Vt. Or this will become this is the apparent frequency. So why do this is called like a Doppler effect? Means the source will generate sound signal at frequency f. Because the relative motion between source and observer, the measured frequency will be less than the actual frequency, apparent frequency or measured frequency. Measured or apparent. This is the f is actual frequency. The signal is generated at frequency f only, but we are going to hear it at some other frequency. Why do that happens? Because of relative motion between the source and observer. This phenomena is called as a Doppler effect. So what is the Doppler effect here? No, because of relative motion between the source and observer, the measured frequency will be slightly different than actual frequency. Why do this happen? Because of relative motion between source and observer. So shall we make a definition for Doppler effect? So what is the Doppler effect? The measured frequency will be slightly different than the actual frequency due to relative motion between source sine, observer or detector, both are same. Okay, got the idea now? So will I hear sound signal of higher frequency or low frequency if I move away from source? Low frequency, no, V minus V naught. Earlier V plus V naught. Here F dash will be less than F. Previous case F dash was greater than F. And now let's make source, let source be in motion. Next condition will take it. Let me bring this diagram instead of drawing many times. Okay, as usual. So here now, what is the condition? The source observer will make it a test, and then let the source be moving. Source is in motion, and the observer is at rest. Then we'll see what is the Doppler effect condition. So first initially it is like this. Now if the source starts moving, tell me like a what will happen? No, you are at rest. You are at rest. Let me wind up things here only. So this is the observer is at rest. The source is going to move. Let me write Vs. What will happen to the distance between wavefronts? Anybody wants to answer? The source is moving, and your physics teacher will be moving towards you, and I'll be throwing gestures. So anything will happen to the distance between gestures. Is going to change. There's a rough diagram I'm giving. I'll be throwing with a speed V or V, some other thing, that one. I'll be throwing the gestures with a speed V relative, no? I'm going to throw the gestures with a speed V relative only. Because earlier I was at touch, I'm throwing. Now I'll be running and I'll be throwing the gestures. So then what is the speed of the wavefront? So it will become V relative. So the wavelength is going to change now. The distance between the wavefronts are changing. So lambda dash is going to change. So this lambda dash is what we'll try to express. Okay, how to bring that one? Lambda dash. Lambda dash should be equal to V relative into T. So this will be V minus Vs. What is F dash is equal to? F dash will be equal to V by lambda dash. So the waves will come and strike with a speed V only. The speed with which you are projecting will be different, no? So this will become V. Lambda dash is V minus Vs. What is 1 by T? Will be F. So this is the apparent frequency. Try to see this one, sir, like we didn't understood. See, like earlier, both are at rest. What is the distance between gestures? I'll be at rest. I'll be throwing for every interval of time t. I'll be throwing gesture. The distance between distance will be same, and it'll be moving. Now I'll be running. Then I'll be throwing it. Then what happened to the distance between gestures should change. So that is what I'm writing. So then what is the speed with which I project? That is what V relative. So that should be equal to V minus Vs. Then we'll proceed like this. Okay, got this one. So if the source moves towards observer, observer is at rest. So source moving. It will generate signal of frequency f, but it will be received at frequency f dash. So this is apparent frequency. F is actual frequency. Already I wrote it. Now the source, let him move away. If he moves away, then also the distance between wavefronts is going to change. In this case, lambda dash, what we write it, V plus Vs, no? V minus of minus Vs, or V relative, I'll write it. Lambda dash V relative into T. So this will be V. So what is F dash equal to? V by lambda dash. So look at what is F equal to 1 by T. This is apparent frequency, it will be received. So like that, what happened? The observer attached, source is moving. So these are the, like this, we can calculate the apparent frequency. So what is the wavelength? I think the wavelength, when the wavelength of the waves received by observer will change when source is moving. When source is attached, the wavelength are not going to change. Okay, later I'll stress it in detail. Okay, if the source and observer both are moving, then sir, how you manage things? Both source and observer